The disaster in Japan has refocused the world's attention on nuclear energy. Several hydrogen explosions have occurred at the nuclear power plant in northern Japan, putting people at risk for radiation poisoning. Normally, when we think of these hydrogen explosions, we think of what you see there on your screen. Mixing hydrogen and oxygen together can be highly flammable. So while it's a great form of energy, it can also be very dangerous if it's not used properly. But we do want to point out that most all of the energy used in this country can be dangerous, including the gasoline you even put in your car. So let's talk for a minute about how it's used when it's used correctly. NASA uses hydrogen to power the space shuttle. The only byproduct of hydrogen power is water. Astronauts actually drink that byproduct. Today, there are more than 300 vehicles on the road in this country powered by hydrogen. So how do we fix this problem of the hydrogen-oxygen dangerous mix? Well, we have a possible solution in today's Big I. The Department of Energy has made a huge breakthrough when it comes to transporting and storing the gas. And here to tell us all about that is Jeff Urban. He works with the Department of Energy as a lead scientist at the Berkeley Lab. He has a title, I will tell you, as long as my arm. So, Jeff, we're just going to call you a super smart guy, okay? That's your new title for today. First of all,
Fair
Jeff,
enough,
great to have you with us. Tell us about this big breakthrough.
Yeah, this really came out of a big dilemma in the hydrogen storage community, which is how do you safely and densely hold on to a large quantity of hydrogen, something that you'd need to power a vehicle, as you mentioned at the outset, but also do so in a way so that you can release the fuel when you want to, on demand, and in quantities that you'd like to. So what we did is we basically engineered a material for which we could take advantage of the intrinsically faster kinetics of really small crystals, nanocrystals in this case, but by working with them in such a way that they're encased or embedded in a gas-selective polymer such that they can be dealt with very safely, just allowing the hydrogen to go in and out, but protecting them from oxygen and water and other chemicals.
So in really simple terms that even, I'll be able to understand here because I'm not a scientist, what does it mean for the folks at home?
What it means is I think we now have a strategy and there's a materials design plan to developing ways to safely and productively use hydrogen as a carrier for energy. And I'm excited about it. I think it's a big advance because historically one has either only been able to hold on to a very small density of hydrogen such that you couldn't really power a car for 300 miles, which is kind of the benchmark. Or else you would really need to really pump very high temperatures or very high pressures to release it. And that's just not practical for working on your everyday vehicles. And
so when it comes to hydrogen myths, can you help us dispel some of them? I mean, how safe really is this energy?
Yeah, well, I think you really nailed it at the outset. So any energy carrier, any fuel has intrinsic dangers. Hydrogen, I'm excited about it because it has a lot of potential benefits. In contrast to gasoline, which we're all familiar with, hydrogen is intrinsically non-toxic, and it doesn't pool on the ground. It doesn't accumulate in that way. It's 15 times less dense than air, and has very clean byproducts. As you mentioned, any of the sort of traditional fuels that we work with day to day, whether it's powering our car or even having a little butane lighter in our pocket, they have dangers that we really, to a large degree, don't think about anymore because we have great safety regulations in place. Probably the biggest danger in cars nowadays is user error.
All right, Jeff Urban, thank you for making it so easy. We told everybody you were a super smart guy, and it certainly sounds like it. So you proved us right.
Thank you.
All right, Jeff, good to see you. Thanks. To check out Jeff's research, head to Allie's blog, cnn.com/Allie. We'll also link you up to the Department of Energy's Hydrogen Info website if you want to dig on this some more.